Good morning. I hope everyone is doing well. I'm certain some of you in the audience have heard about diodes before. However, how many of you know how the diode works? Today, we will explore diodes in the electronics world. What is a diode, its nature and characteristics, and how is it that the diode works are questions I will be answering throughout this presentation. My name is Javier Garces, currently pursuing a bachelor's degree in mechatronics. For those that don't know what mechatronics is, it is a combination of electronics, mechanical engineering, and programming with focus on robotics. I worked as a craft electrician for over a decade before I became an avionics technical inspector, and optimally a basic electronics instructor. I have come across diodes on many occasions, more than I can count actually, although I have never stopped once to ask myself the question, how this component works. I'm sure some of you in the audience can relate to that, don't you? Let's start by answering the most common question. What is a diode? Diodes are mainly silicon or germanium-made semiconductor devices with two terminals that conduct electricity in only one direction, allowing current to pass through them. There are many types of diodes, but the most used one is the rectifier diode. The properties of this diode are that makes it useful for many applications. Next slide. Here's how the diode rectifier looks like, and the symbol used to represent the diode rectifier in the circuit diagram. The two terminals in the diode are called the anode, which is the positive side of the diode, and the cathode, which is the negative side of the diode in the other side. Silicon's diodes are more common because silicon is easier and cheaper to produce or to obtain than germanium and other elements with rectifying characteristics. In the electrical world, there are three types of materials. Next slide. Conductors, insulators, and semiconductors. To understand the difference between one another, let's have a closer look at the atomic structure of the conductor material. Next slide. Atoms are formed by a nucleus that contains protons, neutrons, and the electrons that are negatively charged, and these electrons are orbiting around the nucleus because they are attracted by the protons in the nucleus that are positive charged due to the law of attraction. Opposite charge attracts and same charge repel. As you can observe in the slide, there are multiple layers of electrons orbiting around the nucleus, and they're called shells. Here's an important note. The maximum number of electrons in the outer shell is 8. Conductors have 1 to 3 valence electrons in the outer shell. Some examples of good conductors are gold, silver, and copper. Next slide. Insulators, in the other hand, do not conduct electricity and have 5 to 8 electrons orbiting in the outer shell. Some examples of insulators are ceramic, rubber, and some other polymers based on wood and plastic materials. Then there are semiconductors. These materials, like silicon and germanium, have 4 valence electrons orbiting in the outer shell. Next slide. Like you can see here, this is a silicon atom. Now that we have established what is the diode and the atomic structure, let's discuss how is it the diode works. In the silicon atom, for example, there are 4 valence electrons orbiting in the outer shell. When more atoms of the same substance are present, they bond together, forming a crystal. This bond is called covalent bonding. This combination has the purpose to balance the outer shell to the max possible electron, which is 8. Next slide. These crystals are intrinsic because they are in perfect harmony to each other. In order to induce some internal electron movements, we must mix it with another substance called impurity donor that will compromise this balance. For example, boron. It is a pentavalent material which has 5 valence electrons in the outer shell. And as I said before, the maximum allowed electrons is 8. And if I mix it with a 4 electron with its we form mixtures that contain extra electrons floating, looking for holes to bond. These holes are positive charge. Imagine this process with millions of atoms. We will have a lot of electrons moving that become current carriers. Also, since electrons are negative charge and became the majority carriers, it is said that these materials are N-type material. Next slide. The same principle applies to make the positive or P-type material, but in this case, impurity donors is a trivalent material causing holes to become the majority carriers, which are positive charge. Next slide. When we combine a positive material and a negative material, a positive-negative junction is formed and it's called p-n junction. The region where these two materials meet is called the depletion region that will act as a gate to allow the electron to flow from one end to another. By the process of ionization, diffusion, and recombination. Next slide. Let's now discuss the main diode characteristic, diode as rectifier. First, we need to set some direct current parameters for the diode to work, and it's called bias. Next slide. These rectifying characteristics of the diode come from the p-n junction and the proper bias to operate. There are two types of bias, the forward bias and the reverse bias. The forward bias reduces the potential barrier of the diode and establishes the easy path for the flow of current, while in reverse bias, the potential difference increases the strength of the barrier, which prevents the charge carrier to move across the junction. Now let's apply this concept to the rectification process to convert alternating current into pulsating direct current. Next slide. During the positive half cycle, the diode is under forward bias condition. During the negative half cycle, the diode is under reverse bias condition. The voltage output is measured across the load resistance. During the positive half cycle, the output is positive and significant. And during the negative half cycle, the output is zero or insignificant. This is known as a half-wave rectification. Next slide. There is some references. Here are some references that I think might be of your interest in case you want to get more in-depth information about these topics. So today in this presentation, I went over diode as rectifiers, the three types of materials that exist in the electronics world and their atomic structure, how N-type and P-type materials are created and what happens when these two materials join together. And finally, we cover how diodes operate in it and its rectifying characteristics. Feel free to leave your questions and comments and suggestions down below, and so I can review it and apply it in future presentations. Once again, my name is Javier Garces, and thank you all for paying attention today. Thank you.